All right, so welcome back. Part 2 of solving systems of equations. Again, I'm pretty hungry now. All right. Oh yeah, it's sponsored by Camclaw today. Subscribe to my video channel and get 0% off your next ride at Camclaw. All right, so we saw before we can have an intersection of two lines, and that is called our solution. So when we're solving systems of equations, we can have an intersection of the two lines like we see in these two examples here. Now we're going to take a look at some different examples for number 3 and 4. So number 3, let's simply just start by graphing it like we have been. This will be my blue graph, and this will be my red graph. So for y equals 7x plus 4, let us graph my y-intercept. Step 1. My slope is 7 over 1, but I can't go up 7, so I'm going to go down 7, left 1. 1, 2, 3, 4, 5, 6, 7, left 1. There's my graph there. Get that ruler to be precise. That's a good line there, boy. Yeah, I'm going pro. Nice. All right, so now let's graph my next one. I have 7x plus 1. So I can't really go up 7 here. I'll go the same thing. I'm going to go down 7, left 1. Just so I can get this to sort of fit in my graph. So this will 1, 2, 3, 4, 5, 6, 7, left 1 is about right here. Alrighty. It goes a little bit off the graph, but it's really just an estimate. You'll see what's going to go on for this case here. Alrighty, very good. Get rid of my ruler. Now, we're used to seeing these two graphs, and they have an intersection. In this case, they don't have an intersection because they are two parallel lines. And if you remember from parallel lines, when two graphs in slope-intercept form have the same slope, that means they're parallel lines. They will never touch. So in this case, this is actually our case number 2 now. Case 2. We have no solution. So when you have two lines that don't intersect, that is no solution. They do not intersect. So this is why we have no solution. We have two parallel lines that don't intersect, so no solution. And that is case 2. Now we're going to take a look at our third case. And let's graph both of these here. As you can see, I put these graphs in slope-intercept form just to save us some time, just to get to it. But you'll notice that these are the exact same two graphs. So first, let's graph them. Start with my y-intercept of plus 3. I'll go down 6 because that's my slope. Negative 6 over 1. I'll go down 6, right 1. 1, 2, 3. Alrighty. Whoops. Alrighty. Now, if we have two of the graphs exactly like that, really all that's happening is we're graphing the same line directly on top of each other. So, if we were to graph another line just like this one, well, guess what? We would just put it directly, as you can see here, it's directly just on top of each other. So this is the same exact line. And in this case, what is going on? In this case, for case 3, as we can see, it's the same line. So we have infinitely many solutions. Since they're the same line, they're going to go on top of each other. And any solution for x will satisfy this equation. So, case 3, we have the same line that's infinitely many solutions. So at the bottom here, I'm just going to sum up all the cases for us. So, let's see what we got. Cases. 1, we have one solution. That's our first case that we saw on numbers 1 and 2. One solution. 2, we have no solution. That means parallel lines. No intersection. And case 3, we have infinitely many solutions. And what that means is we have the same line. So those are the 3 cases for these scenarios here. And that's really it for graphing systems of equations. For the classwork, I'm going to have the graphs all done out for you because there's really no way unless I have you submit your graphs. It's too complicated. My goal for this virtual learning is to make this stress-free and as simple as possible, yet effective as possible for you guys. So take a look at the classwork. You're going to have 3 cases or 3 different graphs that are going to summarize each of these 3 cases, and that's really going to be it for our section here. And then the next time, tomorrow, we're going to get a look at how to graph these using technology. So we're going to use Desmos. So that's all for today. Be good, eat lemon protein bars, keep thriving, drink coffee, go outside, go for a walk. Just kidding, it's going to